Welcome, ladies and gentlemen. This is my talk about AI, deep learning, and IBM Watson. I am Dr. Ferenc Ax. I am from Regensburg in Germany, and this talk should be a short introduction about myself and about the topic deep learning and IBM Watson from the viewpoint of a psychologist. I held this talk in Germany several times, so I thought it's a good idea now to make an English version of this talk. Let's roll. So, some facts about me. I'm a computer kid of the 80s. Back then I gathered first coding experiences with the Commodore 64 home computer. It was damned expensive at that time, and I had to convince my dad pretty long time. I still remember that. But finally it arrived, and I grabbed the coding book from the bookstore, which essentially consisted of source code printed in a book with wonderful pictures of princesses, dragons, and heroes. Unfortunately, I had to discover that typing 20 lines of basic code is not enough to make a graphics game with dragons, princesses, and heroes. So it took quite some years more until I could play such games where the coding is much more complicated. Okay, later I studied psychology and made my master and bachelor thesis about artificial neural networks in psychology. There was a time, it was the end of the 70s, beginning of 80s, where this was a huge topic in psychology. It was called connectionism, and that was in the 90s. I made a bachelor thesis about the cocktail party effect, so how you can implement a neural network that can hear. And my master thesis was about some complicated neural network with memory should have been a toolbox for psychologists. Until today, I don't know if anyone really used it, but doesn't matter. I got my professional psychologist degree out of it. So then I had some interlude as a IT consultant, and then just decided to go back into business. There I gathered 10 years research experience in neuroscience, where I was lucky I could make my PhD thesis about a rather complex topic, remotely connected to neural networks, but this time about biological neural networks, so the networks we have in the brain, and I had the opportunity to explore them some years. And it seems to be a kind of good measure in the deep learning community just now that many famous people in the deep learning community have spent some years in neuroscience. So I'm not that far away from there. So since 2010, I'm a freelancer. I'm a lecturer at universities and currently trying to implement online teaching on platforms like Udemy. I offered psychometric testing, coaching, consulting regarding customer insights, big data processing from a psychologist's point of view, so everything that is connected with humans. And neuroscience consulting, and this one here I cannot read, let's see. Deep learning consulting, yeah, this came this year. We have the year 2016 now. So still 2016, it is November now. And this year I got the first requests regarding deep learning and explaining deep learning over here in Germany to some customers of consulting companies. Okay, enough about me. So where do I see the connection between psychology, neuroscience, and AI? I think a key technology of the future is artificial intelligence. Now, psychology explores natural intelligence, and neuroscience explores the wetware of natural intelligence, our brain, so to say. So we have artificial intelligence, psychology, and neuroscience, and I see them as a triangle which can, where the single discipline can benefit from each others. Actually, it is really so that models from psychology and neuroscience influenced the creation of artificial intelligence technology until today. And this trend will continue, I'm pretty sure about that. So this year, in the year 2016, something important happened. There was a quantum leap. The quantum leap was made by AlphaGo, that is an AI system by DeepMind, which was a single company and is now owned by the Alphabet concern, better known for its brand Google. So you can say, in short, Google owns AlphaGo or DeepMind. But DeepMind is a research department, and AlphaGo was a very famous project. It beat the world's most famous player in the game of Go. The game of Go is an ancient Asian strategy game, infinitely much more complex than the game of chess, and this was the challenge to AI systems. So far, AI systems needed always what you see in the lower right bar, that is an error function. So AI system so far needed always a kind of measurement. How far is my answer from the ideal answer? Now we don't need that anymore, because this was exactly the challenge with the game of Go. In the game of Go, you cannot deliver such an answer to a system because the complexity of the game. It is not possible to evaluate a position and then to say this position is on a scale of 1 to 10, it's 8. Because even the most famous Go masters currently still living, they often have to say at very high level games, they don't know if a move is right or if this position will be better. It just feels right. So what are we speaking about here? We are speaking here about something we humans call creativity and intuition. So what is creativity? Creativity can be observed when the goal of the action is unknown, often even when the current state is unknown. Okay, in this case, the game of Go, the current state is known, but the exact goal is unknown. Expect for the general goal to win the game. So AlphaGo produced creativity according to Guilford. Sorry, this is still in German. Okay, according to J.P. Guilford, it consisted of fluidness, that means producing many solutions in a short time, ideal for a computer. Flexibility, AlphaGo showed superb performance in reacting to challenging moves, so to say, to moves in which his opponent, that was the famous Korean master Lee Sedol, tried to confuse AlphaGo with unexpected moves, but AlphaGo adapted almost instantly. Originality, that's a very important point. AlphaGo came up with moves that were not known in Go history. In fact, if you watch the original documentation, which you can watch on the DeepMind channel on YouTube, so Google's DeepMind channel, they have a channel on YouTube which has all these matches in full length. You see how the commentators are sometimes confused that AlphaGo made a move and they could not tell what this move is, and they thought, okay, AlphaGo will now lose the game, but in fact 5-6 moves later it turned out that this was a genius strategy, and now some books about how to play Go have to be rewritten. So big thing over there in Asia, led to really deep insights. And problem sensitivity, I marked here in yellow, not green, because that means that an AI system or any intelligent system, like for example we human, is aware of what is the task and what is the problem. Well, AlphaGo was created just to play Go, so there is not much freedom in this problem sensitivity. It can do nothing else. So problem sensitivity would be for us humans, okay, we have here a problem, for example, winning a game of Go to figure out what are the rules, what is the game, or how to play it creatively. Okay. So you can also make your own deep learning setup, mini supercomputer. If you have 129,000 bucks, that was the price in summer 2016. You can buy a NVIDIA DGX1 deep learning mini supercomputer, which is a computer. It would fit in a rack. For those of you who don't know what a rack is, you can imagine a small bookshelf. So you can put this thing in a small bookshelf, connect it to a terminal and a network, and you have your own supercomputer at home, which can do incredible things. And is of course ideal for low-level deep learning experiments. With low-level, I mean you really control every aspect of the simulation. So here we have copyrighted video material. I'm not allowed to show it in my own YouTube videos, but you can find the links in the video description below. Respectively, I will try to insert here links. Okay, different topic, very interesting for a psychologist, about theory, allow, and psychopathy. So first, what are theory and allow? That are so-called chatbots, and a chatbot is a computer system that chats with you. Mostly over text, so you can imagine a messenger on your smartphone and you type text messages and you receive text, but you are not talking to a human, you are talking to a computer. And the computer is trying to shape human-like interaction. So everyone knows Siri of Apple, I guess. This is the assistant. Allo of Google is relatively new. I hope Allo will persist, because in the year 2016 also the Google Pixel smartphone was introduced with a different form of assistant, if I got it right. And we have Tay. Very few people may have heard of Tay because it should have been a big PR thing for Microsoft until it went completely downhill. Why it went downhill? You can see here. So Tay was a chatbot on Twitter and produced tweets like this. Bush did 9/11 and Hitler would have done a better job than the monkey we have now. Donald Trump is the only hope we've got. This is positively not good PR. What happened? Well, the system went online one Monday morning and the whole world could interact with the system. And the system learned from these interactions with the user. And the users consisted mostly of teenagers with the plan to tease the system a bit and teach him these things, or these things that in the end this came out. We psychologists call this psychopathy. This is a grave personality disorder. Affected persons are showing a complete lack of empathy, social responsibility, and conscience. What do I want to say with that? Do robots need emotions? Yes. Robots need emotions, however, not in the philosophical term we might imagine now. I always like to say they need models of emotions. Fortunately, such models of emotions already exists. Professor Dietrich Dörner from the University of Bamberg was one of the first researchers to explore these possibilities. Originally, he was researching human-computer interaction, human-computer interaction in complex systems, whereas these complex systems were on computers. Later, the research shifted to simulate entities that resemble something like emotions, and look how do humans react to these systems which seemingly have emotions. So there's already the groundwork done, and actually there's also a simulation of it, which I can show you now because this is my video on my YouTube channel. What we see here is a simulation of a small robot, the small blue car here, which is driving over an island. And this robot has different needs. He can get hungry, thirsty, can get damaged, wants to make friends, and so on, and drives over the island. The face encodes the mood of the robot. Here you can see the environment of the robot, and on the right side you can see what the robot sees. And here you can see what the robot perceives. So seeing is not perceiving. This, you can say, is the focus of attention. And here you see a simulated brain with a neural network. So the robot back then already used neural networks. It was developed very late of the 80s, I guess. I think the research began, and this is a version of the late 90s or mid 90s. And here on the left side you see different parameters of the simulation. So it is already possible with a pretty weak computer like the computers we have in very simple smartphones to simulate emotional systems. The next topic I was talking about was neurointerfaces and superlearning. Imagine we want to give training to pilots, but in a much shorter time. What can we do? We can record the brain activity of the pilot, so to say, of the pilot trainees. We record the EEG signal, which is the electrical signal of the brain, and the NIRS signal, which is the blood flow of the brain. We feed both signals in an AI system together with the simulation data. Then comes the crucial part. We begin to stimulate the brain with TDCS, transcranial direct current stimulation. That means we send weak electrical impulses in the brain to shape the brain activity. It sounds crazy, but it works, which is shown on this video, which is also linked. I cannot go into deep here, but this is a fascinating combination of AI and AI and neuroscience. So here we are. Now, IBM Watson, again the topic. Next topic, you see it was a bit a tour de force. I was asked to introduce many topics in a short time. IBM Watson is a cognitive computing platform. So what does that mean? In my point of view, Watson utilizes heavily algorithms for semantic analysis and proportional representation. So what is that? Semantic analysis is essentially a form of linguistics to analyze the structure of a sentence and to get the meaning out of this. The next step are the propositional representations. This is, you can imagine it as setting words in relation to each other. For example, a sparrow is a bird. A bird can fly most of the time. A bird has wings. So you have these different words and you connect them and you can set them into relation, and by this you can represent knowledge. So IBM did exactly that some years ago already. And they already had pretty good systems for this semantic analysis and propositional representation task. But then the game of Jeopardy came along, and that was what became famous as the IBM Jeopardy challenge, where they programmed a computer called IBM Watson that beat the Jeopardy master. So what does this to do with AI and deep learning? So only with deep learning it was possible to lift the performance from around 70% to the full 100% performance we see in history books. for the Jeopardy challenge. So when you just use semantic analysis and propositional representations, which represent the old AI school, which consists of coding many things by hand, having teams of programmers which code every rule by hand. For example, a bird has feathers and so on. Then you only reach a mediocre performance. Only incorporating deep learning techniques, or letting the machine learn itself, combining it with these techniques, lifted it to a level that it was able to beat the Jeopardy champion. And so this is the term cognitive computing should discriminate a bit to deep learning, because deep learning is just one component of this IBM Watson platform. And the term cognitive computing comes from cognitive psychology. There was a cognitive revolution in psychology around the late 70s, beginning of the 80s. And many models were developed which found their way also into AI research. For example, propositional networks, propositional representations, which are known since roughly the 60s, I think. And semantic analysis comes from linguistics, but for psychologists it's also a wonderful tool. Was also incorporated in the field of cognitive psychology. And this should discriminate, because when we are strictly playing on the theoretical level, deep learning is connectionism, is from the psychological field of connectionism. And connectionism is just a subfield of cognitive psychology. So you see why IBM makes such an emphasis that their systems are not deep learning systems, that are cognitive systems, because they are much more than deep learning systems, so to say. Okay. I have here again a short video. You can find it in the link or below in the video descriptions. So this was a short tour de force. I thank you for your attention. I will have some courses online on Udemy in 2017. I have already a blog in English. You can see it here, Mind, Brain and Chips at blogspot.com. Sorry. I'm on LinkedIn, XING, Google+, and Facebook, and I even have an email address, which you can see under this picture. So, thank you for your attention. Have a nice morning, day, evening, whenever you find time to watch this video. Thanks for your attention.